100 million barrels, refined daily into gasoline, powering global mobility and economies. Inside this complex, crude oil undergoes a dramatic transformation, a 12-stage journey to become high-purity gasoline. Our journey begins with crude oil's arrival, a complex mixture of hydrocarbons requiring separation and purification. First, desalting removes corrosive salts and minerals, protecting delicate refinery equipment from damage and fouling.
Heated to 370 degrees Celsius, crude oil vaporizes completely, preparing it for the primary separation process.
The atmospheric distillation tower, where crude oil separates into its primary fractions based on boiling points.
Naphtha for gasoline, kerosene for jet fuel, diesel for transportation. Each fraction finds its specific purpose.
Vacuum distillation applies intense suction, allowing heavier molecules to be separated without excessive heat. The fluid catalytic cracker, breaking heavy gas oil into lighter, more valuable gasoline-range molecules.
Catalyst is continuously regenerated, burning off carbon deposits to maintain peak catalytic activity.
Catalytic reforming transforms low-octane naphtha, creating high-octane components essential for modern gasoline.
Platinum catalysts drive molecular rearrangement, boosting octane ratings above 985 for engine performance.
Alkylation combines light gases, creating alkylate, a clean-burning, high-octane gasoline blending component.
Hydrotreating removes sulfur and nitrogen, meeting stringent environmental regulations for clean fuels. Precision blending combines 12 different components, creating the final gasoline formula with exact performance specs.
Additive packages are injected, ensuring engine cleanliness, performance, and long-term fuel stability. Every batch is tested at 8 quality parameters, ensuring compliance with industry and government standards. Certified gasoline is stored in floating roof tanks, minimizing evaporation losses before distribution to stations. From crude oil to high-octane fuel, a continuous, precise process powering the world's journey.
24 hours a day, 7 days a week. The continuous transformation of crude oil into energy. Supertankers deliver over 2 million barrels, connecting global oil fields to local refinery operations. Storage tanks hold weeks of supply, ensuring continuous refinery operation between crude deliveries.
Central control rooms manage every parameter. Temperature, pressure, and flow rates constantly optimized.
Heat exchangers recover 90% of energy, preheating crude oil using waste heat from other processes. Final heating to 370 degrees Celsius, achieving complete vaporization for effective separation. 30 separation trays create distinct fractions, each tray collecting specific hydrocarbon chain lengths. Steam stripping enhances separation purity, removing light ends from heavier drawn products. Atmospheric residue undergoes vacuum distillation, recovering valuable heavy gas oils under reduced pressure. Vacuum systems reduce pressure to 20 millimeters of mercury, enabling separation at just 400 degrees Celsius.
Catalyst temperatures reach 700 degrees Celsius, cracking heavy gas oil in just 3 seconds residence time.
Coke combustion heats catalyst to 700 degrees, providing the thermal energy for continuous cracking.
FCC produces 40% gasoline yield, the heart of modern gasoline production in the refinery.
Catalytic reformers operate in series, each reactor achieving higher severity for maximum octane improvement. Reforming converts naphthenes to aromatics, dramatically increasing octane from 70 to over 100.
Hydrogen is recovered and recycled, maintaining reaction pressure and catalyst stability throughout the process.
Alkylation occurs below 30 degrees Celsius, creating branched hydrocarbons with exceptional anti-knock properties.
Acid catalyst is 98% recovered, continuously recycled to minimize consumption and operating costs.
Alkylate boasts 100+ octane rating, the premium clean-burning gasoline blending component available.
Hydrotreating removes 99% of sulfur, producing ultra-low sulfur gasoline meeting 10 parts per million standards.
Amine systems recover 99% hydrogen, recycling valuable gas while capturing sulfur compounds. Klaus units recover 99% sulfur, converting harmful hydrogen sulfide into saleable solid sulfur. 15 components blended in precise proportions, creating consistent gasoline batches meeting exact specifications.
Additive packages comprise 1% of volume, delivering cleaning, stability, and performance enhancements. Inline mixers create 200 divisions, guaranteeing perfect homogeneity in the final gasoline product.
CFR engines measure anti-knock properties,
determining the exact octane rating for gasoline labeling.
Distillation tests confirm volatility profile, ensuring easy cold starts without summer vapor lock issues.
Gas chromatography identifies 200 components, verifying composition and regulatory compliance precisely.
Floating roof tanks reduce emissions by 90%, minimizing hydrocarbon losses to the atmosphere during storage.
Pipeline transport moves gasoline efficiently. One pipeline replacing 800 tanker trucks on the highway.
Tanker trucks deliver the final product, completing the journey from crude oil to consumer fuel. From complex chemistry to simple mobility, the continuous transformation powering our modern world.
Hydrogen production enables clean fuels, removing sulfur to meet stringent environmental standards worldwide.
Cogeneration captures waste heat, producing 60% of the refinery's electrical power needs internally.
Cooling towers recycle 95% of water, minimizing fresh water consumption through continuous circulation.
2,000 gas detectors provide continuous monitoring, ensuring immediate response to any potential hydrocarbon release.
Flare systems ensure safe operations, converting emergency hydrocarbon releases to carbon dioxide and water vapor.
Biological treatment removes 99% hydrocarbons, transforming process wastewater into reusable quality water.
Quality control runs 300 tests daily, ensuring every product batch meets exact customer specifications.
Planned turnarounds involve 1,000 workers, completing 15,000 maintenance tasks in 30 days. Catalyst changes optimize process efficiency, restoring unit performance to design specifications.
Non-destructive testing examines equipment integrity, preventing failures through proactive inspection programs.
Process simulation models optimize operations, identifying efficiency improvements before implementation.
Distributed control systems manage 15,000 process loops, ensuring stable operation 24 hours daily.
Drone inspections capture 10,000 images, creating 3D models for precise maintenance planning and execution.
Asphalt production utilizes the heaviest fractions, creating durable paving materials from residual components.
Cogeneration achieves 85% efficiency, significantly reducing the refinery's carbon footprint intensity.
Water recycling reduces consumption by 40%, treating and reusing process water multiple times.
Multimodal distribution ensures supply reliability, utilizing pipelines, marine, rail, and highway transportation.
Continuous emissions monitoring tracks performance, ensuring compliance with all environmental regulations. Safety procedures govern every task, from unit operations to maintenance activities and inspections.
Renewable fuel production integrates new feedstocks, bridging traditional refining and emerging energy technologies.
Industrial operations and environmental stewardship. Advanced technologies minimizing ecological impact continuously.